By now we all know, for running any application in your mobile or your PC, operating system creates a process of that application, which is nothing but the part or an executing instance of that application. But do you know there are two more ways a process gets created inside your system? Yes. To know more, stick with us till the end of the video. When your system is up and running, operating system creates and terminates lots and lots of process. But this is operating system creating process. What if you want to create process? Yes, my friends, this is possible. Operating system itself gives you the facility to create and terminate your own process. In fact, it also gives you the facility to account your own created process, which simply means that you can decide how much time your process should take on the processor of your system. Now you will say, why we need to create process? Well, to answer that, for example, a process is having a lot of work. So what you do is you create more processes and you divide the work so that you can get results faster. So in order to get results faster, you create more process. Make sense? Okay. In this video, we'll discuss two most common process operations that happen and which are process creation and process termination. So let's start with process creation. Now in this we are going to cover four concepts which are process creation terminology. Second is what reasons that lead to process creation. Next is the situations that happen when processes are created inside your system. And lastly, my favorite part, which is how you can create process inside your system. So let's begin. When you start your computer, the first process that gets executed in your operating system, Unix or Linux operating system especially, is the init process. Now, if you Google this question, there is a lot of debate going on that which process runs first, which next, and which has the process ID 0. Some say it's the wrapper process, some say it's the shared init process, and majority of the people say it's the init process. For now in this video we'll consider that init is the main process or the process which starts first inside the system. So the init process is the parent process of all the process that gets created inside the system. So the init process creates more processes which are called as child processes, and so the init is the father, or we can say the parent of all these processes. You can see the parent process creates a child process. Both have their respected process control blocks, that is PCB. Operating system has provided them with PIDs, that is process IDs, PPIDs, that is parent process IDs, and lots more information. You can see the child PPID, that is parent process ID, is the PID of the parent process, which in this case, in this example, is 2246. Likewise, a parent can create multiple child processes. Child process can also create new process, and then that time child will act as parent of newly created process. Now let's see what reasons lead to process creation in your system. The first is the computer system, when it starts running, it itself creates some processes for management of all the programs inside your system. That is, the operating system is itself responsible for creating lots and lots of processes. So that's number one reason. Next is when the user or you give the command or issue a command to create a process. The simplest thing or the simplest command you issue is just by clicking on an application to open it, and that's when a process gets created inside your system. And third is when running processes creates more process. That is what we discussed earlier. That is the parent and child process concept. So here the running process creates more process, divide that work and get the results faster. Now let's come back to the parent and child process concept. Now what generally happens is the parent is waiting for the child to complete its execution, and then the parent continues his work and then it eventually terminates. But in this example, this is the process A and this is the parent process. This calls the fork system call, and don't worry about the system call, I'll cover this fork system call in a while. And this system call creates a new process, that is the child process. It is the process B. So A is the parent and B is the child. Then B starts its execution, and after it exits from the system, it gives signal to the parent process that I am exiting, and then the parent continues until then the parent is waiting with the wait system call, and eventually the parent also terminates. So the wait system call in the system is for child processes to finish, and lastly the parent process will be terminated. Now suppose the parent and the child processes are created in your system. Now there are 4 situations that happen inside your system. First is parent and child processes are executing simultaneously. So there is no waiting and all. Next is what we discussed earlier, is parent is waiting and child is completing its execution, and after the child executes, the parent starts and eventually the parent also terminates. The third situation is when the child process is the duplicate process of the parent process and is created in the same address space, that is on the same RAM memory. So there is a lot of dependencies between these two processes. And last situation is when the child process is created in completely different memory area. So there is no dependencies, or with the parent process and the child process there is no connection. Now let's come to the practical part of the video, and my personal favorite is how you can create process inside your system, and that is using the fork system call. Now I won't be covering this fork system call in too much of detail, but just to overview this system call, this is used to create new processes, and these processes are called child processes. What most important thing to remember about fork system call is it returns values. If it returns 0, that means the running process is the child process. If it returns positive number greater than 0, then it's the parent process which is running. And if some negative number is written, then there is some error caused in creating the process. Now you will say, why does a fork system call returns the values? To see that, let's see fork in action. This is a C language code for process creation. You can see on the second line of the main function, fork system call is executed. And then there are 3 conditions we discussed earlier. That is, if PID is less than 0, then there is error for process creation. Then if PID is greater than 0, then it's a parent process. Or in the else part, which simply means PID is equal to 0, that is, it's the child process and the PID of that child process is written. So when we execute this program to call the fork system call, Unix operating system will make 2 identical copies of address space, that is the memory on RAM, one for the parent and one for the child. So 2 different spaces are created but very identical, and both the processes will start their execution from the next line following the fork system call. That is why we have to distinguish between the parent and child, as they start their execution from same line. This is done by the return value of the fork system call. So you can now know the importance of return values of fork system call. Using return value, we distinguish between the parent and the child process inside the system. This was all about process creation. Now let's talk about process termination. There are two ways the process gets exited or terminated from the system. That is normally or abnormally. Normally is when the process has finished its job, done with all its execution, and abnormally is when some interrupt occurs inside the system, and that's why the process has to exit from the system. Some more examples may be like error or some interrupt causing, or we can say the memory on the RAM is limited, or we can say the time on the processor is exceeded, or we can take errors like divide by zero error, or memory or array index out of bound, that is accessing the memory which is not exit, or we can say the input output device failures, or the permissions denied, or we can say the cascading error, that is when the parent exits or terminates, and that is why the child also has to get terminated. Or we can say the protection error, that is when you are trying to write on a file which is read only file, and so on and so forth. So there are lots and lots of examples related to process termination inside your system. Now, do you know that when process gets created, or when multiple processes are running inside your system, they all communicate with each other using signals? Yes. So signals are the one that they use to communicate with each other. So what are signals, how they are created, and how process use them, and how we can send signals to the system, all in my next video. One more important thing, that my next video is in Marathi language. So if you don't want to miss the next exciting stuff, consider subscribing. Until then, keep learning by doing, keep learning, keep growing. See you in the next video. Bye bye and take care.